All right, today in statistics, we're looking at the fundamental counting principle. This is the fundamental counting principle right here. What it means is the number of ways to do an event is M, and the number of ways to do a second event is N. Okay, and that tells us then the number of ways to do both events is going to be M times N. Now, what that means is something like this. Suppose a man has 3 shirts. Okay? And he has 4 pairs of pants. How many outfits can this man wear? Okay, so what we'll do is we'll call these 3 shirts A, B, and C. These are his 3 shirts. And his 4 pairs of pants, we'll call it pants number 1, number 2, number 3, and number 4. Okay, so the answer to this is going to be 3 times 4, which is 12. There should be 12 different outfits he can wear. But if I draw out the sample space, now the sample space is all the possibilities that he could wear. So he could wear shirt A with pants number 1, shirt A with pants number 2, A with 3, A with 4, and there's 4 different outfits he could wear with shirt A. And then he could have B with 1, B with 2, B with 3, and B with 4. C with 1, C with 2, C with 3, and C with 4. And you can see there's 12 possibilities of outfits he could wear. This is the fundamental counting principle. One thing I like to look at when talking about fundamental counting principle is telephone numbers. All right, in a telephone number, we have our area code, which consists of 3 numbers. Then we have our prefix number, which is another 3 numbers. And then we have our line number, which has 4 numbers. This is a typical telephone number. Okay? Now, a couple things about this phone number. This number in the area code, it cannot be 0 or 1. Because see, 1, you dial 1 for a long distance number. And then 0, you dial 0 first if you're wanting to do a collect call. So this number cannot be 0 or 1. Same thing goes here. This one right here, it cannot be 0 or 1 either, because that would confuse the system thinking you're doing a long distance phone number or a collect call. So those numbers cannot be 0 or 1. Okay, so now the question is, how many phone numbers are possible? How many phone numbers can you have in the United States? Well, since this cannot be 0 or 1, that means it could be 2, 3, 4, 5, 6, 7, 8, or 9, which there's 8 possibilities for that. All right, this digit right here, it could be 0 through 9, which is 10 possibilities. So we got 10 possibilities there. We got 10 here. Now, this one again cannot be 0 or 1, so that's going to be 8. Right here, 10 numbers, and then these numbers could be anything down here. Okay, let's get it all on the screen. So now, how many total possible numbers can we have? I just multiply these because this event, there's 8 possibilities. This event, there's 10 possibilities in each one of those. And so how many total ways? We multiply those up. So let's do that. 8 times 10 times 10 times 8 times 10. Which is, look at that, 6,400,000,000. Let's make sure we did that right now. I got 8 times 8. I got 2 8s. times, they got 1, 2, 3, 4, 5, 6, 7, 8 tens. So I'm going to do 10 to the 8th power. Just make sure we got that right. Yeah, we did it right. 6,400,000,000 phone numbers. That's how many phone numbers are possible for the United States. Well, the problem is we're running out of phone numbers. Now, used to on your area code, this is my area code. Let me write it on here. Oops, area code. This is a prefix. And this is the line number. Okay, used to on the area code, this number here had to be a 1 or a 0. That's all it could be. So like used to in Kentucky. All right, so let me see if I can draw Kentucky a little bit. Okay, here's Kentucky. All right. Used to, there was a line about right here where Louisville is and something like that. And this side over here was 502, and this side over here was 606. And we had 2 area codes in Kentucky. Okay, well, and like I said, this number in the middle of the area code had to be a 1 or a 0. So in Kentucky, they were both zeros like this. Well, we started running out of phone numbers. There wasn't enough phone numbers to go around, so they changed that where this middle number in the area code could be any number now. So like, for instance, our area code's 270 and the middle number's a 7. All right, so what's happened now is we've run out of these phone numbers, so let me see if I can draw the state again here. Okay, there's Kentucky. Not too good. Now we have this. Right here where Louisville is, this is 502. And then right over here where Lexington is, this is 859. And then there's this line right here. Now they brought in, this is 270, or could be 364. They've split. Used to it was just 270 here, but now they've split it up because we've run out of phone numbers for that. And then all this over here, outside of these 2 circles here, this is 606. So now Kentucky has 5 different area codes. And still we keep getting more phone numbers. Like, you take, for instance, you may know somebody that has a cell phone. They've got a business cell phone, and then they have a phone for their house. This person may have 3 different phone numbers. I know people that have, 2 or 3 different cell phones. And so because of all these cell phones going around the country, we're running out of phone numbers. And so eventually I look for us to add a digit to our phone numbers. See, right now we've got the 3-digit area code, the 3-digit prefix, and the 4-digit line number. I look for us to add a number, like maybe to the line number, have a 5-digit line number now. I look for us to do something like that, in the next near future. Now, so here is one exception to. There's 6,400,000,000. I didn't think about this, but the prefix 555 is not used. So really, if you want to be technical about it, there's 6,399,999,999. There's actually this many phone numbers because this one here is not allowed. This 555 prefix number, the 555 prefix number is reserved for the phone company. And I don't know if you ever noticed, but like if you're watching a movie, the movie will have 555-3412. That'd be the phone number because this is non-existent. This is reserved for the phone company, and there's no such number for that. So pay attention to this in movies or in television sometimes they'll have this 555 as a prefix, which is non-existent. There was a movie that was out a few years ago. You may have seen it, Bruce Almighty. And in that movie, there was a telephone number that was supposed to have been to call God. And that number, I had it wrote down here. Yeah, here it is. 776-2323. This was a phone number in Bruce Almighty to call God, and they did not use the 555 prefix, and so people started calling this number asking for God. And so when Bruce Almighty came out on DVD, they switched this to 555, so that would decrease the number of calls that people would make to try to call God here. And back in the 80s, there was this song that was out. It's called 867-5309. This is a phone number for this guy's girlfriend, Jenny. And people had this phone number because that was an actual phone number. And people had that phone number, so they would get all these prank calls, people calling asking for Jenny, and so that got on their nerves and everything. But this is a little bit about phone numbers and how to count them up. Let's look at some problems here, and I'm missing the first page. Well, backwards. There it is. All right, so let's look at some problems here that we might be encountered with. A shirt company has 4 designs, each of which can be made with a short or a long sleeves. There are 6 color patterns. How many different shirts are available from this company? All right, so you have your design, you have your sleeves, and then you have your color. You have 3 different events here. All right, for the design, there's 4 ways to do that event. The sleeves, there's 2 ways to do your sleeves. And there's 6 colors. So how many different shirts can you have? You multiply these up, and that would be 48. So here's my answer right there, 48. Okay. Let's go to number 2 here. Use the fundamental counting principle. A singer-songwriter wishes to compose a melody. Each note in the melody must be one of 13 notes in her vocal range. Okay. How many different sequences of 4 notes are possible? Now what we have here, we got a sequence of 4 notes. 1, 2, 3, 4. So this could be something that goes ding, 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 or it could be ding, 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 ding. You know, there's different sequences of notes you could have. All right, so this one, there's 13 notes possible for that one. There's 13 notes possible here. There's 13 here. There's 13 there. This could be ding, 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 ding. They could all be the same, or they could be different. Ding, 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 ding. So anyway, how many possibilities are there? Well, I multiply those up. And so now this is just be 13 to the 4th power. So if I do 13 to the 4th power, that's 28,561. And so here's my answer right there. Okay. Number 3 here. How many license plates can be made consisting of 2 letters followed by 3 digits? All right, so we're going to have 2 letters, and then we're going to have 1, 2, 3 digits. These 2 letters, and these are digits. There's 26 letters, so there's 26 possibilities for that event, 26 possible for that one. Digits, we're talking about just numbers, so there's 10 here, 10 here, 10 there. How many total? I multiply them up. Okay, so let's just 26 to the second power times 10 to the third power. 26 to the second power, 10 to the third power, and it's right here, 676,000. Okay, number 4. How many different codes of 4 digits are possible? We got 4 digits. If the first digit must be a 3, 4, or 5, and if the code may not end in 0. All right, so here we go. We got this code, 1, 2, 3, 4 digits. Okay, now it tells us in here the first digit must be 3, 4, or 5. So there's only 3 possibilities for this first digit. Then it says it may not end in 0. So this last digit right here cannot be 0, which means there's only 9 possibilities for it. But there's nothing mentioned about these, so I can have 10 here and I can have 10 there. And so I multiply these up. Okay, I think it's going to be 2,700 right there, 2,700. Okay, number 5. A restaurant offers a $12 dinner special that has 5 choices for an appetizer, 10 choices for an entree, and 3 choices for a dessert. How many different meals are available? All right, so we got an appetizer, we got an entree, and we've got a dessert. All right, we got 5 here, 10 here, 3 there. And so I multiply those up. That's going to be 150. 150 ways. Okay. Number 6, we've got 2 more here we're going to do. A realtor uses a lockbox to store the keys to a house that is for sale. The access code for the lockbox consists of 4 digits. All right, here we go. We got 1, 2, 3, 4 digits. The first digit cannot be 2. So this first digit cannot be 2, which means there's 9 possibilities there. The last digit must be even. All right, now if you look at your numbers, 1, let's start with 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, now it says on your note that 0 is considered even. 0 is even, 2 is even, 4 is even, 6 is even, 8 is even. There's 5 of those. So the last digit, there's only 5 possibilities there. It does not mention anything at all about these 2, which means we've got 10 possibilities there and 10 possibilities there. And so now multiply these up. So it's going to be 4,500 ways. Okay. And then the last one here. Assuming that no questions are left unanswered, in how many ways can a 5-question quiz with 4 multiple choice questions be answered? All right. We have 1, 2, 3, 4, 5 questions. And it's a multiple choice of 4 answers. So I've got 4 answers here. I've got 4 answers for that one, 4 for this one, 4 for this one, 4 for that one. So I multiply these up. Okay, so that's going to be 4 to the 5th power. So 4 to the 5th power is 1,024. There's 1,024 different possibilities of answers on this. So that just goes to show you there's only one way to get them all right. So you have a 1 out of 1,024 chance of getting every one of those right by guessing. If you just put numbers at random, that's what your possibility would be to get them all right. So very small chance. Anyway, this is the fundamental counting principle. And if you have any questions, let me know. Have a good day.